Okay, guys, now let's take a look at part 2 of writing arithmetic sequences in two different types of equations. But first, let's remember that instead of an x, we are now going to use the variable n, and instead of y or f of x, we're going to use a sub n. So if you see other mathematicians or resources where they still use x and y, that is okay. And instead of m for slope, we're going to call it the d, and we're going to call it the common difference. So arithmetic sequences are types of linear functions. So let's go back to our first example, and we know that our common difference was 2, 4, 6, 8, 10, 12, and so on. The recursive form or formula simply just tells us what the common difference is. Each term is defined as a function of its preceding term. So in this blank will be our common difference. So this is the recursive form. A sub n equals y equals. This notation just means if I know the previous term and I add the common difference, I can find or determine the current term. So n sub n minus 1, that just means the previous term. We will not insert any value here or here. All we're going to do is fill in the blank with our common difference. So first of all, our first term is 4, because we need to tell the reader where to start. A sub 1 is 4. And then here's the recursive form. Our output or our sequence equals the previous term plus 2. So this is all we have to do is fill in the blank with the common difference. Let's take a look at the second example. So to write the recursive form, we do need to locate our common difference. So we are going down 5. So our common difference is minus 5. So we're going to tell the reader, let's start at 25. And then here is the actual recursive form. And it's a fill in the blank. My term equals the previous term plus my common difference of minus 5. So if I were writing this out, I would not put plus negative 5, which is fine. I would just put minus 5. It's just a fill in the blank. Okay, now let's go to the explicit form or explicit formula. And this is a more useful formula, a useful equation, because we can find any term in the sequence, where with the recursive form, we would constantly have to subtract 5, subtract 5, subtract 5, on and on if we want to find, say for instance, like we're going to find the 20th term here, but we're not going to just apply the common difference. So here we have 3, 8, 13, 18, 23. So these are going up by 5. So our common difference, D, is going to be 5. So in this one, the explicit formula, we will fill in the blank. We will fill in our first term, and then we will fill in the common difference. These two things I'm circling are the fill in the blanks. So A sub n, this is the explicit form, which just means the precise, clear form, because we can clearly find any term in our sequence once we fill this in and simplify. So A sub n equals our first term plus our common difference times n minus 1. Now, we are going to simplify this, and it's going to be put into what looks like slope-intercept form. So we are going to distribute the common difference and then combine like terms And now we're going to use this explicit form that's been simplified to find the 20th term. So I'll make an ordered pair. The 20th term is, and we're going to plug it into our function. 5 times the 20th term minus 2 is 100 minus 2, and that gives us the 20th term is 98. So simplifying from explicit gives us what looks like slope-intercept form, but again, if we were to graph this, we would not graph an ordered pair on the y-axis because there's no such thing as a 0th term in our sequences. But this does help us identify any term in our sequence. So way on down the line, our 20th number would be 98. Okay, let's try a second example. Here we have 25, 20, 15, 10, 5. So this one we are going down 5. So our common difference, our D value, is negative 5. Our A sub 1 value is the first term in our sequence. So this is the explicit form. But let's simplify to be able to use it to find any term like our 20th number. So we are going to distribute this negative 5. And then combine like terms. So I have a negative common difference, a negative rate of change. And now let's find the 20th term. So the output of the 20th term is going to be multiplying it by 20 times negative 5 plus 30. So the 20th term is going to be negative 70. So if I kept subtracting 5 on the 20th time, I would